So we are going to deal with what you kindly invited us to participate in, which is your survey for cabin. Let's see, there we go. So we want to acknowledge Sarah, of course, for being the person that corralled us and invited us, and also the collector, along with Petra and Paula. Thank you very much. They were lovely samples. We are working throughout the Athabasca watershed, including the Treaty 6, 8, and 10 territories, Métis First Nation of Alberta, regions 1 and 4. And we need to acknowledge your funders, which were the Alberta Conservation Association and the Alberta Eco Trust. So let's start with CABA, the Canadian Aquatic Biomonitoring Network, abbreviated as CABIN. I was thinking a nice old pioneer cabin would have been a nice background, but it was, to me, it's a national bioassessment framework that standardizes, and that's the important thing, I think, is it standardizes the collecting protocols so we can compare between watersheds, between years. Basically, the sky's the limit for comparisons because everything is standardized. Your site data is essential, even though it takes you hours to collect all that associated site data, and let's face it, maybe 20 minutes to collect your sample of invertebrates. And all that standardized allows you to try and make a determination of the health status of any aquatic ecosystem in Canada. Lovely. Now, why and how can we use aquatic organisms like we have here in these pictures? These are all Alberta specimens. Some of them actually, I believe, are actually from the Athabasca watershed. How and why can we use them to monitor the health of aquatic ecosystems? You know, they're nondescript little things everybody likes for fishing, but what makes them useful? It's the fact they're in situ biomonitors. So if you look at these on the right of this, let's get my laser pointer going. You look, these are standard, this is from Merritt & Cummins, the standard North American manual for identifying aquatic invertebrates. You look, stoneflies and mayflies. A lot of the mayflies are in the watershed as larvae for a year. Okay, the majority up here, close to 60%, but there are some that are up to 2 years. So suddenly anything at 1 to 2 years, they're going to show up. If you assume it's a degradation of habitat or a pollutant, they're going to pick it up. Stoneflies, a significant number are out at 2 years or more. Again, all these different groups that we're expected to sample for and identify. Then you want to start looking at some of the really scary things. Look at the number of days that larvae develop in some of the fly groups. Okay, yes, it's a small number, but those are still significant. All right. Now, because I didn't have experience up in your watershed per se, I want to talk a little bit about how to sample, and this is an example from the castle. So this is a shout out to Sophie, if you're, I think you're here. This is one of our sites that Diana and I have been collecting. And you notice Cabin says you want to optimize where you're collecting to get a portion. So you want to get in these riffle areas. You want to get in these still areas in a proportion of your tick sample that matches the proportion of this run that, you know, so this you can't get in, it's too deep and it's too fast flowing. There's pool up here that even in the extremely dry conditions this past fall, it was still way over my head. So pointless to try and sample, okay? And we'll come back to these lovely little darlings here in a minute, Ebotanics, because there's a story to this. So cabin is 3 minutes of sampling mayhem to standardize the level of effort. That's important. 3 minutes standard. And you're supposed to use a zigzag sampling across the stream to integrate all this microhabitats. You want to optimize the microhabitats to get everything that's representative of that run of your river. All right. And again, it emphasizes directly adjacent to the stream bank can be important because there are aquatic macrophytes that may be there that have specialized things feeding on them. So let's look at what you might say. And if anybody wants to shout out and question something, feel free. If you're going to try and zigzag across, you got some shallow, still stuff here. You want to get all the way across. This is fairly deep. That's sort of halfway up to beyond my knees. Zigzag across. We want to get, there's a little bit of emergent stuff here. Keep on going. We can't sample this really deep water. It's plain and simply too deep to get into. All right. So that makes sense. I've tried to optimize everything to get that run. And there is your problem. It's observational. And this is where, when you're talking about you went out and did sort of pre-site selection, that is important. Because without that, you would have missed what we call the Ebotanic Pool. So our son was standing here and hey, Dad, look at all this. And quite frankly, it looked disgusting. It had lots of algae growing in it. And you think this is absolutely horrible water. Why sample it? But it is part of that stream run. You should sample there. And if you did that, that is what you would have found. That is what our son Cameron saw. And they're absolutely darling. Some of you, I see Alex and Cheryl and are here, and Adam Martins. I expect you know Ebotanids. It's important to look at the biology. There's 6 species known in Alberta of this genus. They're usually associated with spring streams further north into the lakes. There's actually one species that is also known from Alberta that actually occurs as far north as Ellesmere Island in Hazen Lake. I think that might actually be the northernmost record for a caddisfly in Canada. And it has a tolerance value of 3. Now we'll come back to that, but that is basically tells me that water isn't that bad. Now, these things are so bizarre in a sense. What we do know of the biology, a lot seem to be largely parthenogenic. So it's basically all females. Some would say that's much better. And it's a case of they graze on algae and diatoms. So it makes sense I'm finding them in that pool habitat. They're algal grazers, all right? And they're so bizarre, they actually have gland, it's been shown in a European species, and probably the same for all of them. They have glands on the prothorax that they can actually release a compound that paralyzes predators. So rhyocophilic caddisflies, which we'll also see that are also in your streams, actually will get paralyzed trying to pull these little guys out of their case to eat them. I mean, bizarre, but so neat. So let's look at your streams, and feel free